Welcome to a new part of the ISM Statistics 1 exercise set, this time with an exercise on measures of dispersion. Let's take a closer look at the exercise. A group of students have been asked how many hours per week they spend watching online or offline shows. The results are summarized below. What do we have to do with this data set? First off, calculate the range, then calculate the interquartile range, calculate the corrected variance, and finally calculate the corrected standard deviation. Before we, however, start doing anything at all, we take the data set and we arrange this in ascending order. So we start with the smallest values, that's 2 times the 0, 2 times the 3's, the 4, 10 and 12, and then the 24 and 31. Because if we have this ordered data set, a lot of the different exercise parts go much smoother. We can see this directly for the first part where we have to calculate the range. The range is defined as the difference between maximum and minimum. And well, maximum, that's the largest value in the ordered data set. Minimum, that's the smallest value in the ordered data set. So we can just take the largest, the 31, and the smallest, the 0, and calculate 31 minus 0, and we get, as a range, 31. Relatively easy. Similarly easy, we can calculate the interquartile range, which is defined as the difference between the third quartile and the first quartile. Third quartile, or the 75% percentile or quantile, and the first quartile, the 25% percentile. How do we get those two values? Well, we can calculate first off, consider first off the number of observation, multiply this with the corresponding percentage. So for the first part, 0.75 times 10. This result will then be rounded upwards to the next highest integer, and this gives us the position of the respective value. So here we calculate 10 times 0.75, getting 7.5, and for the other one 2.5. The next highest integers are 8 and 3. So we look up the 8th and the 3rd value and getting 12 and 2. The difference of those two is 10, so our interquartile range is 10. Here we can add the interquartile range actually is the size of the box of a box plot. So our box plot here would have a height of 10. This as a background information, we carry on with the corrected variance. To get the corrected variance, first off we need the arithmetic mean. This we can easily calculate by just adding up all the different values and dividing this by 10, giving us a value of 8.9. Then we use this arithmetic mean in the following formula for the corrected variance. This at a first look might look relatively complex, which however it isn't. You just have to go on, take all the different values of the data set and square them. Add this up, add the square weight values up, and divide this by n minus 1. So number of observations minus 1. So here divide this by 9. And the second part, this is n divided by n minus 1. So here we have 10 observations, so it's 10 divided by 9 times the arithmetic mean to the power of 2. So we see here we just added up the squared values, divide them by 9, minus 10 divided by 9 times the arithmetic mean as calculated before, the 8.9 to the power of 2. If we calculate all of this, we get as a result 114.1, which is our corrected variance. Well, there's only one step left, that's the corrected standard deviation. This, however, is relatively easy. We can copy the corrected variance from the previous part and just calculate the standard deviation by taking the square root of this number. So the square root of 114.1 is approximately 10.6818, giving us thus the standard deviation. This then also concludes this exercise. I hope all of you enjoyed listening and learned at least something from this exercise. And well, until next time, see you and goodbye.